Every shop wants that mirror finish. You want that polished look, and it doesn't matter if you're on a lathe, mill, or a grinding machine. But our parts are complex with sophisticated geometries and tight tolerances, and that can make finishing a daunting task. And when you add automation to that, it ups the challenge. So we're here today with the Norton team. They're gonna help us uncover more of the finishing process. We're gonna dive into more of the automation process and learning how if you do it correctly, it'll help you get that job done. So that's it. You and I, we're gonna be hanging out today learning how to finish the job with automation. This is Norton. We're heading on over to the Abrasive Process Solutions Lab, where they have a team of automation experts that help manufacturers like you with your own real parts, real production challenges, and test, verify, and perfect the finishing process before it ever gets back to your shop floor. I promised you an automation expert, and I have one of the best, my friend Nathan Jackson.
All right, Jacob,
good to see you again, man. I like that we keep coming back. So today I really want to dive into finishing. It's a challenge in any metalworking industry. And when you start trying to add some variables to that, like automation, it can look even more challenging, a little bit daunting. What are you hearing from customers in your network that come here to help you figure out their finishing issues?
Consistency is the biggest thing we hear from customers. A lot of consistency issues with finishing. You know, you can imagine if you have a shop full of operators, every operator is going to grind slightly differently. They're going to use different force, different contact time. There's going to be fatigue, depends on whether they've had lunch or not that day, that sort of thing, right? But with automation, we can control these variables so that we're always grinding with the same force and with the same process every single part.
So it sounds like you're trying to find an actual proven process and create a proven process, correct?
Exactly. So automation is going to allow you to have consistent pressure, repeatable motion, and predictable outcomes, even on your most complex parts.
Nice. And those results don't happen by accident. It comes from that process getting proven, tested, verified throughout the manufacturing facility. I'd love to jump into the robotics cell and get after it.
Absolutely. Let's go take a look.
So it's time to get some work done. We're here with our robotic cell. We're here in the APS lab. Nathan, what are we gonna be going over?
So what we're gonna be doing today is kind of simulating a finishing process using our 6-axis industrial robot that we have here. On the end of the robot, we have a spindle that's gonna rotate our part as we polish it. So first thing we're gonna do when we're polishing is take it to these belts. We can try a bunch of different belt grit sequences to kind of dial in which products are needed.
Nice.
One other thing that's nice, you know, we've been talking about this constant pressure. This head has compliance built in, which means throughout the entire cycle, it's gonna be constant force.
And that's gonna help the robot shine. You have consistency here, consistency there. That's what you need with automation.
Exactly. And then once we've done that, we're gonna bring it to the buff and do a little bit of buffing just to kind of get that final shiny mirror finish that people expect from their finishing process.
Nice.
And with the robot, every time we run this, it's gonna have a consistent, repeatable result because every parameter is gonna be the same.
Before any part can make it into the robot cell, there's a lot of work that goes down here at the APS lab. You have to break down an application and establish a process, and I have some experts to help me do that. Mike Chappelle.
Good to see you.
How's it going, sir? Good to see you again. Andrew Biro.
How are you?
Good to see you, man. Mike, what are some things that you're seeing from your customers out in the field?
Well, when a part first comes to us from the customer, they're asking us to help them with the challenge, and they present us what the final part needs to look like. And then we use that information to design what we have to do inside the robot lab to create that process and give them that net result in the end.
Nice. And it's not like you're starting from scratch. They have a process. You're just trying to help them optimize it.
That's right. And the use of automation, we're able to take what they're coming to us with and then enhance it and let the automation really work in their favor.
Nice. So Andrew, when it comes to taking some of these variables and putting them into a process, how do you go about it?
A lot of what we have to do, to Mike's point earlier, is sort of work backwards from the end goal. And a lot of what we do is, do we want to use a belt? Do we want to use a wheel? That's dependent upon how we can approach the part and what limitations there are with the geometry of the part, the material on the part, and the finish that we want to hit. The other thing we have to look at is what sort of pressures and forces do we need to apply, right? How do we optimize all of that to work with the abrasive in order to give us the right result? Focus of the lab is really about tweaking all of those small changes so that they work in harmony with the abrasives that we select to give us the final solution and a final recipe for the customer. The really nice thing about the APS cell is that we can do a lot of that development work here in the lab so that we're not taking up precious time at the customer site.
Nice. I think I'm actually gonna go head over with a finished part with Nathan in the metrology area, and we're actually gonna check out some surface finishes. How you get a finish on a part is very important, but what that finish actually is even more crucial. Nathan, let's dive into the first one.
Sure. So the first thing we're going to do to ensure we've kind of met the customer's requirements, most people have a surface finish requirement. So we would use a profilometer here to get a surface finish reading and confirm that we have met our customer's requirements. So this is our raw part we're looking at here after roughing.
Okay, rough part, 119. We're gonna switch these out, pop that one there. This is the finished one we did earlier.
Correct.
And that is a 3.
So for you, that would typically mean if you want a mirrored finish, a lot of times what that means is like sub 5 or 6 micro inches.
Nice.
So by hitting a 2 to 3 range in this part, we've shown that we've gotten that mirror finish that the customer would be looking for.
Now, what's another process that they would be looking for out of the lab here?
So another thing we can do is use a microscopic camera to take very close-up images of the surface just to kind of see how that scratch pattern on your finished part looks.
And so you would pop in the rough one.
Yeah.
You'd obviously dial this in. You can see that there. You'd pop this off, pop the finished one back on, and then you'd be able to see that there
Exactly,
as well.
yes. And like I said, because this is a camera, we can take images as well and use that for documentation if we're trying to compare different grit sequences or different finishing products as we talked about before.
That's cool. And I think the biggest thing here is the fact that you're not just machining the part and then saying to the customer, all right, here you go. You machine the part, you verify the part, and you're giving the customer that confidence to continue to move forward.
Exactly.
So we've seen how an automation process needs to get proven here in the lab. And now I'm with Brad Harity. How's it going, sir?
Good to see you again.
National Account Manager for Norton, here to represent the customer. What do you think the customer really gets out of coming to a place like this? They have their finishing challenges. They're stepping into the scary world of automation. What do you see from them?
It takes the guesswork out of it. They get to come in and see their parts being worked on and see what the possibilities could be, right? And that's great because that builds confidence when thinking about going to automation, especially in a critical final step.
But it's also a little bit of trust, right? Because you may not know my process. I know my parts really well, and now here you go, take them from me.
Absolutely. So, you mentioned trust, and I mentioned it's, proof of concept. So what that really does is it says, hey, we take on that risk, that initial investment. It allows the customer to see an overall performance in the process and how it could work without having to make any capital investment on their own shop floor. So talk about trust. We're hoping that helps build them by showing them process what it could be.
So confidence, trust, that going both ways,
Yep.
and helping out with some of that capital investment. That's what I'm learning today, man.
Yeah. Hey.
I appreciate everything you do for the customer.
Likewise. Thanks
Thanks for having me today.
Thank you.
Finishing may be one of the last steps in the manufacturing process, but as we've seen today, it plays a critical role in your part quality and your process performance. And you need that process, you need an application, and you need to figure out a way to validate results if you want to optimize manufacturing. That's what we learned here today at the APS lab with the Norton team. And now you and I, we know how to finish the job with automation.
For more metalworking tips and industry best practices, stay tuned for the next how-to episode and subscribe to the MSC Industrial Supply YouTube channel, a source of original manufacturing content built to make you better.